All right, yesterday we started working with circles and triangles as an introduction to trigonometry, and we learned about our sine and cosine function. And in that, we talked about all of our rotations in terms of degrees. Now we are going to start talking about our rotation in terms of another unit called radians. So to start off our notes, let's just get this definition down. A radian is the angle made when the radius is wrapped around the circle. Now there's a graphic here that kind of shows that. If we have this radius here, okay, if I take that exact same length and wrap it around the outside of my circle, that's going to make up the angle of 1 radian. We have a nice little graphic that I'll show on the next slide to show you. But basically what that means is since the circumference of our circle is 2 pi r, that is equal to 2 times pi times r. Our radians are always going to usually be in terms of pi. So we have pi radians equals 180 degrees. That'll get us halfway around our circle. So if we wanted to convert some stuff, which we will in a second, we're going to use this idea that 1 radian equals 180 degrees divided by pi. And the last thing you'll see is since we are connected to pi here, most of the time when you see radians, we're going to keep it in terms of pi. And you'll see what I'm talking about once we get to examples 3, 4, 5. Once you have that down, watch this little graphic real quick, and you'll notice that we take out a radius, it traces around a circle for us. But if we take that radius, move it to the outside of our circle, and wrap it around the edge of it, that constitutes 1 radian. Now, if we kind of repeat that 1 radian around the circle, it's not going to perfectly match up. It takes a little over 3 radians to hit that half circle, and actually it's 3.14 something, which is pi. And so if we do that twice to get around our circle, it takes 2 pi radians to get there. So that's just a little conceptual understanding of what radians are, but for the effect of this class, we're just going to treat them as a different form of measurement. So it's important that we can bounce back from radians to degrees, just like we can bounce back and forth between inches and feet. So to convert from radians to degrees, we're going to use this formula here where degrees are equal to our radians times 180 divided by pi. And a good way to remember this, that the 180 is on top, the pi is on bottom, is we are going to try to cancel out our pi. Degrees won't be in terms of pi, but radians will. So if we have 2 pi over 3, all we got to do is rewrite this in a formula, okay, where my degrees, deg, is equal to my radians 2 pi over 3 times 180 over pi. And if we multiply this straight across, you'll notice that these pi's cancel out. And then we can just punch into our calculator the numbers that we have. We have 2 times 180 divided by 3. So let's do that real quick. 2 times 180 divided by 3. And that equals 120. And I'm going to throw our little degree sign on there to signify that that's the units that we're in. Now, if you didn't cancel the pi out and you actually plugged pi into your calculator, which you can do, or plug it into Desmos, which you can do, you'll get the same thing and those values will cancel out. So let's try this again with our example 2. I'm going to rewrite this formula here. Our degrees are equal to 7 pi over 6 times 180 divided by pi. And again, those pi's cancel out, which is really nice. So we're just left with our numbers, 7 times 180 divided by 6. And we're going to get 210 degrees for example 2. Now, if we can go one way, radians to degrees, we can also go the other way, where we're going to go degrees to radians. And just like we started with radians in terms of pi, we're going to try to end with our radian measures in terms of pi as well. So we're going to have some fraction. Let's try to simplify it down so that we still have pi in our answer, but it's easy for us to work with. So if we start with this 120 degrees, okay, We're going to start by rewriting this new formula, which you should copy down in your sheet. And this is basically the same thing, just reversed, where pi is on top, 180 is on bottom. So we're going to have radians equals our degrees, which is 120, times pi over 180. Once you set it up, all we need to do is start simplifying our fraction. So to start, we have, it looks like we can divide out 10 from each just to make this a little more manageable. So I have 12 pi over 18. And I'm going to kind of move this down a little bit just so it's a little easier to see. It looks like we could probably divide out a 6 from both of these as well and come up with 2 pi over 3. And you'll notice this is actually exactly the same example, just working in the other direction as we did with number 1. Notice how we went from 2 pi over 3 to 120 degrees. Well, in example 3, we just worked the opposite direction where we started with 120 and we brought it down to 2 pi over 3. So same thing happens with example 4 and example 2, where we know our answer should be 7 pi over 6. So if I go back here, we know we should get 7 pi over 6 for example 4. Let's work through it and try it though. So we set up our formula. Our radians equals 210 times pi over 180. Okay, and then I'm just simplifying. So it always helps me to divide out a 10 right away because we have those, both of them ending in zeros. So 21 pi over 18. And kind of knowing what I'm working towards here, but also recognizing that I can divide out 3 from both of them. I can divide out that 3 simplified down so that I get 7 pi over 6. If you want to make a note here that we are just simplifying, that might be helpful for you. All right, last one. This one we haven't covered yet, going the other way, so we're going to do it from scratch. We're going to take our 45 degrees. We're going to rewrite our formula. Radians equals 45 pi over 180. This time I can't divide out 10, right? Because that 45 ends in a 5, but I can divide out 5 to at least make it a little more easy to see. So if I divide out 5 from both the top and bottom, I'm going to get 9 up top and 36 on bottom. So 9 pi over 36. And you might be able to recognize that, hey, I have 36 is divisible by 9. So I can simplify that down even further. I have 1 pi over 4, which is the same thing as writing, hey, that's just pi over 4. So the last thing we want to be able to do with our radians today is use them to calculate sine and cosine. At the end of yesterday's lesson, we were just using our calculator to calculate these things. Very easy to do in Desmos or our calculator, but our settings need to be correct. So if we go into Desmos and do this, we need to make sure that radians are selected in our settings menu. And if we go into our calculator, we want to make sure to click that DRG button and then select rad as our units of measurement. Otherwise, we're going to get the wrong thing. So let's see what we're talking about here. We're going to calculate it for sine of pi over 4, cosine of 7 pi over 6, and sine of 5 pi over 3. If I go into my Desmos here, notice how it kind of defaults to radians. Sometimes it might default to degrees, though, so always check it out. But we can toggle between these two things to get an answer. Let's say I make a mistake to start and accidentally use degrees. So I'm trying to do sine of pi over 4. I type that in. If you want to type pi, just literally type pi divided by 4. And I might think that's my answer to start, but let's again check that settings. Notice how it says it's in degrees. And if I switch it to radians, that value is going to shift depending on whether or not I'm in radians or degrees. Look how that value changes. So it's important that we have radians selected here in order for us to get the right answer. So in this case, we have sine of pi over 4 equals 0.707. So I'm going to round to 2 decimals. That is going to be 0.71. Oh, that had a little typo in it, 0.71. Now let's do our next two. Cosine of 7 pi over 6 and sine of 5 pi over 3. Cosine 7 pi divided by 6. And the last one is sine of 5 pi divided by 3. And again, look at all these values here, how if I have this done incorrectly in my settings, all of the values change and they become very different. We saw that yesterday in our exit ticket with a few people where we didn't have the settings right. So make sure that we're working in radians when we're with radians and degrees when we're with degrees. So we have, it looks like negative 0.87 for both of our answers here, the cosine and the sine. So I'm going to write that in, equals negative 0.87 and negative 0.87. Now, when you get to practice, make sure you're minding which units you're actually supposed to be using. We're going to have some calculations with radians and some calculations with degrees today.